Today, we're diving into the story of Bert. Now, this is the AI model that literally taught machines how to understand language. Not just one word at a time, but the whole shebang. It was a single breakthrough that totally changed how computers read, and really, it laid the groundwork for the AI that you and I use every single day.
All right, so to really get this, we've got to start with a huge problem that computers have always had with language. And it all comes down to one word: context. You see, words can mean different things, right? And figuring out the right meaning, well, that all depends on the other words around it.
Okay, look at this sentence. Is the guy heading to a riverbank, maybe to do some fishing, or is he going to a financial bank to withdraw some cash? Now, for us, it's pretty simple, right? If the next sentence mentions money, we know what's up. But for an AI, that kind of ambiguity is a massive hurdle. And that right there, that's the core problem of context. So, before our hero Bert shows up on the scene, language models had this major blind spot when they tried to solve this context puzzle. You could almost think of it like they were stuck on a one-way street. So, models like OpenAI's early GPT, they were what we call unidirectional. They read a sentence from left to right, which sounds normal, right? That's how we read. But here's the catch. When the model tried to figure out what a word meant, it could only look at the words that came before it. It was totally blind to what came next, and that's often where all the juicy, important clues are hiding.
And this is the moment where everything changed. In 2018, some researchers at Google published this groundbreaking paper. What they did was they figured out a way to give AI a complete 360-degree view of the sentence.
They called it BERT. And yeah, that stands for bidirectional encoder representations from transformers. It's a total mouthful, I know. But the only word you really need to remember is that first one, bidirectional. That was the absolute game changer, the key to all its power. It was designed from the ground up to see the whole context of a word, all at once.
So think about it. Instead of that one-way street, Bert could look at words to the left and to the right of a word at the same time. And that let the model build a much, much deeper, more nuanced understanding of what that word meant in that specific sentence. No more guessing with only half the story.
Okay, so how on earth do you teach a machine to think like that? I mean, you can't just have it read a book from left to right anymore. That's the old way. Well, the Google researchers came up with two seriously clever training games to pull it off.
So game number one is basically a fill-in-the-blanks puzzle, but, on an absolutely massive planetary scale. They called it the Masked Language Model, or MLM.
The idea itself was pretty simple, but really powerful. They'd take a sentence and just hide about 15% of the words, replacing them with this little mask tag. Then the AI's job was to guess what the original words were. Now, to do that, the AI had no choice. It was forced to look at the words on both sides of that blank, and by doing that over and over, it started learning the relationships between words in a really, really deep way.
All right, game number two. This one was designed to teach the model something else that AI really struggled with: understanding the relationship between whole sentences.
It was called Next Sentence Prediction, or NSP. Here's how it worked. Bert was shown two sentences. Sometimes sentence B was the actual sentence that came right after sentence A, but other times it was just a totally random sentence, yanked from somewhere else entirely. Bert's simple job was to guess, is this the next sentence or not? And this is what taught it about logic and flow and even cause and effect.
And these two games together, they perfectly set up this really powerful two-step process that makes Bert so versatile and efficient. Okay, so step one is called pre-training. Think of this as Bert's general education. It's playing those two games on just billions and billions of words from places like Wikipedia and a huge collection of books. It's not learning to do anything specific yet, it's just learning the fundamental rules of language itself. Then you have step two, fine-tuning. Now you can take this super educated but still general model and give it a tiny bit of extra training on a specific task. And just like that, it becomes an expert at something new, like answering questions or figuring out if a movie review is positive or negative. So, the big question, right? Did all of this clever training actually pay off? And the answer is a huge, emphatic yes. The results weren't just good, they were absolutely revolutionary.
When BERT was released, it didn't just nudge the field forward a little bit. No, it took a giant leap. It smashed existing records and set new state-of-the-art results on 11 different language tasks. We're talking everything from answering questions to understanding logical connections between ideas.
Let's put some numbers on this. There's this thing called the GLUE benchmark. You can think of it like a decathlon for AI language models. It tests a whole bunch of different skills.
Well, Bert's large model came in and scored an 82.1. To put that in perspective, the previous record holder, OpenAI's GPT, was sitting at 75.1. That's a huge jump. And that difference, it might not sound like a lot, but that 7.7% absolute improvement was like a seismic shockwave through the entire AI research community. Seriously, gains like that just don't happen often. It signaled a fundamental shift in how we do things. Bert had just set a completely new bar for what was even possible.
When you boil it all down, by being the first model to truly look at the whole picture, Bert gave machines a sense of context that was way more human-like than anything we'd ever seen before. It really did lay the foundation for so many of the tools we use every day, the powerful search engines, the chatbots, the AI assistants. And it leaves us with a really exciting question to think about. What's the next great leap in understanding going to be?